Good morning, Year 4. I hope you're all well and I hope you're all ready to begin our new maths topic all about area. So this will be our next topic for the next week. So you're going to be learning and you're going to be an expert and you're going to be able to find the area of many different shapes, all right? Before we have a look what area is, we're going to start with our daily fluency. Now, question number 4 is quite wordy. Spend your time on it and think about what it's asking you to do, all right? Spend the next 3 or 4 minutes, pause the video and write down these answers to your daily fluency, please. Off you go. Okay, 69 divided by 3. Well, we could partition this into 60 and 9, dividing both of these numbers by 3, giving us the answer of 23. Number 2, 5 multiplied by 12. Well, you could do either that or 12 multiplied by 5, whatever you find easiest. The answer is 60. Number 3, find the product of 3, 4 and 5. Well, when we know that when we're finding the product of numbers that they are being multiplied together. So 3 multiplied by 4 is 12, multiplying that by 5 giving us 60. Finally, a laptop costs £4,000. A record player costs £472 less than a laptop. Really important word, that less. How much does a record player cost? Well, we know that our sum would be 4,000, subtract, take away 472. Now we know we could use the compensation method to make this easier by doing 3,999 subtract 471. That could make it a bit more manageable. And the answer would be 3,528. Okay, some more retrieval questions here just to help you with today's lesson about area, okay? You don't have to write these down, just make sure you have a think, maybe discuss them with someone if there's someone next to you, or just have a think, okay? So again, pause the video and have a think about these questions, please. Okay, so a 2D shape. 2D shapes are flat. They are completely flat, such as a square, a triangle, whereas a 3D shape has depth to it, so it's 3D. And this could mean like a cube or a cuboid. So a square would be a 2D shape, whereas the cube would be the 3D shape. Okay, name these 2D shapes. Well, hopefully you got these ones. A triangle, which was an equilateral triangle, meaning all the sides are the same length. A rectangle, a circle, a square. Did you get this one? An isosceles triangle where the two lengths are the same and then the bottom length is different. Well done if you got those. Number 3, what do these symbols mean? Well, hopefully you remembered that the first one means greater than, the middle one means equal to, and the third one, the final one, means less than. The information is going to be really, really important for you today. It's going to really help you out with your learning, okay? So make sure if you need to pause this now to just remind yourself that you pause yourself now, okay? Okay, so are you ready for today's learning? So first of all, before I even teach you anything today, I'm going to ask you to find your worksheet and answer question 1. So I've got question 1 here, and what you need to do, don't worry about working with a partner. If you have got a grown-up or a sibling that you could work with, that's fantastic, but you can do it alone. I would like you to use 4 sticky notes. Now, if you don't have any sticky notes, what you can do is cut out 4 different squares from a piece of paper, but the squares must be the same size. It's really important they're the same size. I want you to see how many different rectilinear shapes you can make using just those 4 sticky notes or those 4 pieces of paper. I have got a picture here of rectilinear shapes to help you remind yourself what a rectilinear shape is. So Year 4, can you remind me what a rectilinear shape is? Well done. It is a shape that has straight edges and also right angles. Okay, so you can see the right angles here. Fantastic. So it's not a shape that goes in a circle or the edges are not cornered, shaped. I'm doing some awful hand gesture here, but shaped, but they're actually all straight, creating right angles in the corners, okay? And then answer question A and question B, all right? Pause the video, don't spend too long, spend about 5 minutes and then come back to the video, okay? Have fun. Okay, did you manage to make lots of different rectilinear shapes? I bet you did. That's going to really help you out to understand what area is. Some of you might have never heard of area before, some of you might have, but let's see what it is. So, with your sticky notes or pieces of paper, you may have made a shape that looks like this, where it's just straight. You may have made a shape that looks like this, where it looks like a bigger square. You may have made a shape with 3 squares going across and one of them underneath, or it may have gone to the other side, or the other side, or the other side. You may have made the same 3 squares across, but the 4th square might have gone in the middle on top, or on the middle below. And you may have also done like a zigzag shape. Now all of these shapes have the same area. Can you explain how you know that? They each are being made by using 4 squares, 4 of your sticky notes or 4 of your pieces of paper. Fantastic. So you can see here that they are using 4 squares to make the area. Now you might be still thinking, Miss Newman, what is area? Well, let's have a look. So here we have a square. It's a 2D square. We know this because it's flat. Now, inside the square is its area. And if we take this square outside, that is its area too. So area is the amount of space that's taken up by the 2D shape. Let's have a look at some more examples. We could see the areas of these shapes. The first one here, what shape is that? It's a triangle. And we know the area would look like this. The second shape, the area would look like this. And that's because area is the space taken up by a 2D shape. Because area is the space taken up by a closed 2D shape. So with the last example, do you think we could find the area of this shape? Give me a nod or a shake of your head. You're right. We couldn't find the area of this closed 2D shape. Because, is it closed? No, it's not closed. Well done. Now, we kind of know what area is now. It's the area taken up inside a closed 2D shape. Is this a closed 2D shape? Yes, it is, isn't it? What type of shape is this? It's a rectilinear shape, isn't it? Well done. Now, we know that we want to find the area inside this shape. Now, Tiny thinks that we could fill the space with something and count how many of that something fit inside. Now, Tiny has chosen to use counters. Now, he's put the counters in the shape, trying to fill the area until he thinks he's filled it. Then he counts the counters. Can you count the counters? See how many are there? Just pause the video and count the counters for me. So, did you find out that the area was 14 because there were 14 counters there? Well, actually, here's Ron and he says, hang on a minute, there are gaps in your shape. You haven't worked out the full area of that shape because you've left gaps. And we can't leave gaps. We need to make sure that all the gaps are filled. So what we could use is a different shape. We could use squares to fill the gaps because we know we're using rectilinear shapes. We're finding the area of those shapes. We know that squares are going to fit perfectly because all the rectilinear sides have corners. So we can start by filling our shape with squares until we think we've filled the area. Now, year 4, are you happy that we've filled the area? Me too. Now you can count how many squares there are, and that will be your area. So there are 12 squares, which means the area of this shape is 12. Okay, we've got some more shapes here, and I've got 3 people who are all going to show you how they think they're going to calculate the area of this shape. Your job is to be a detective, and your job is to find out which one is wrong, okay, or which 2 are wrong. Now, the first person is filling in lots of squares, so she's using squares. And she's found that the area is 12. She's used 12 squares. Have a think, is that correct? Then the next person is also using squares, but they've used 3 big squares and 8 little squares. They counted the squares, they had 11 squares, so that's their area. Is that correct? The final person has used squares all the same size. She hasn't left any gaps, and she's counted her squares and she's said there are 20 squares, so the area is 20. Who do you agree with? And why are the others incorrect? Pause the video and have a think. Okay, so if we think to this first person, not only can we see gaps in our area, but the squares are also overlapping. So that isn't going to be efficient. It's not going to be right, is it? The first person hasn't used squares all the same length. They've got some big squares, some little squares. So we know that's not accurate either. But the final person is accurate. She hasn't got any gaps in her area. The squares are not overlapping and they are the same size. So the first one is incorrect, the second one is incorrect, and the final one is the correct way to work out area using squares. Okay, one of our final tasks, and then I'm going to let you carry on with the rest of the worksheet before we move on to today's problem-solving questions. So we want to compare the areas of these shapes using less than, greater than, or equal to. Now you are superstars at using these. You're better than me at this because sometimes I get confused, don't I? So if we look at the first example, we have two triangles. One is bigger than the other. Can you think which sign we are going to use to compare them? Pause the video and write that down, please. Okay, let's see if you got the same answer as me. So we know the triangle is less than, the first triangle is less than the second triangle because it's smaller. Well done. Got another example for you here. They do get a bit trickier. Can you pause the video again? Write down the symbol you'd use, please. Okay, well this time, they are both circles. They both look pretty similar, but this one has got a hole in the middle, meaning that the first one is greater than the second one. The final example here, pause the video and have a think, please. Okay, so this one was using our square method. So we could find out the area by counting the squares. We know that this shape has used 1, 2, 3, 4 squares. It has an area of 4, whereas this shape, 1, 2, 3, 4, also 4 squares. So actually, although they look a bit different, they are equal. But if one of these squares was smaller than these 3 squares, would they still be equal? No, because the squares have to be the same size. Great work. Okay. What I would like you to do, using these shapes in front of me, I would like you to have a go at creating a shape that is smaller than this shape with a smaller area, and then another shape that is larger with this area. Using your squares to have a go at seeing if you can draw a shape with a smaller area and another one with a larger area. Pause the video and have a go at that, please. Remembering your squares to be the same size. Okay, off you go. Okay, so let's see if you got similar to me. So if I wanted to draw a shape with a smaller area than this shape here, we know my area is 4. There are 4 squares. So this shape must mean that it has to have an area of less than 4 squares. I have chosen 2 squares, giving me an area of 2. If I wanted a shape that was bigger than this shape, I could make a rectilinear shape that looks like this. I have an area of 1, 2, 3, 4, 5, 6. I have used 6 squares to find the area inside this shape. So this shape is larger than this one. Okay, now it's your turn to have a go at the rest of the questions on the worksheet. Pause the video here, please, and off you go. Okay guys, so we're going to do the problem solving questions on another part to this video. So if you head over to part 2, I will be talking through today's problem solving questions. Thank you for your hard work and listening so well so far, year 4.